going to be filtering in. Real quick, if you guys want to check out this Slack, or alternatively, scan this QR code. This is for anybody who was at yesterday's lesson. I felt that it was rushed. I assume you guys probably felt similarly, but if you can just give me a little bit of feedback real quick. It's just 2 questions. Basically stuff you want me to spend more time on as I'm doing it, and also, was I in fact too fast, etc. So this will help me sort of gauge how we do the lesson today. Take a look. Okay. I assume that's going to be everybody at this point. Okay, so that's good data. That's sort of what I was thinking. So Rid and I were talking and we realized we didn't really explain why React is useful and why everyone uses it now and why it was such a huge upgrade over what we had to do before. So before we jumped into React and TypeScript and whatnot, we were dealing with raw HTML. The airplane page for Hoya Airlines, I think it was called, was just all HTML. There was no React, there was no JavaScript, just HTML. That works great for single web pages like that. As soon as we're trying to do something like YouTube or an Instagram landing page or something that's very complex with a lot of moving parts, this is immediately going to become very difficult to scale. You think of like web pages from like the 90s as these like single static pages that had maybe some animations on them and that was it, because that's what was easy to do. So I have an example here of just an old style non-React, no fancy libraries, nothing website. Let me show you the code real quick. All HTML, this is just a single HTML document. We're doing buttons. That's I guess just what we're doing today and yesterday. So this is an HTML document. You guys have written these before. We have our head up here. What we have here that we didn't have before is a script. I'm going to go into that in a second. And then in our body, which is going to be what's actually displayed on our page, we have an h1 tag counterexample. We have a button that does onClick. It calls the increment counter function, and it says increment. And then we have a paragraph here, or a p, sorry, p tag. It says count. And then within this, we have another tag saying that the ID, it's a span where the ID is equal to the counter, 0. So here's what this actual JavaScript is doing. I talked about the DOM a little bit yesterday. Basically, the DOM is a document object model. And the DOM is what, in effect, is being thrown up on that web page over there. The browser looks at the DOM, and it renders the page for us. Now, when I'm talking about the DOM, each element on this page has some HTML attributes to it. And the one that we care about in this one is count. We have to actually edit the inner HTML for count to make it be displayed differently on the page. So here's the script. We do know JavaScript by now. So var count is equal to 0. So we're just going to set the initialize to 0. We have a function called increment counter. It just increments count. And we have this line here that's kind of funky. Document.getElementById counter.innerHTML equals count. There's a lot going on there. Document is our actual HTML document. GetElementById is an HTML function which selects the element on the page with its ID. Now we know about IDs when we did CSS. We can see down here that the span tag over here has an ID equal to counter. Now we are changing that inner HTML, which is just an attribute of this HTML, every single time that we run this increment counter function. We just increment the count and then we change the inner HTML of this span element to be what our new count is. This doesn't look that bad. Again, this is just a button. It's not going to be terrible. And we click it, we can see we're incrementing the count. And same as before, there's no databases here. Nothing's being saved, nothing's being cached. So if we refresh the page, back to 0. This is old JavaScript. There's no React, there's no .jsx or .tsx. Basically, it is an HTML document with a script tag here, which defines our JavaScript, where we actually edit the DOM. This, again, isn't that bad if we're editing one thing. Start thinking about the scale of, again, the YouTube homepage. The amount of stuff that's on there that can be edited makes this style of development prohibitive pretty quickly. So React was developed at Facebook because of this problem. It was a nightmare to write this stuff for the amount of microservices and stuff going on at Facebook to actually just show what is being displayed on the page. Complete nightmare. So let's take a look at how React's a little bit different. I'm sure I have a button here somewhere. Okay, I believe this is running on localhost 3000. Okay, something similar going on here. This is actually, I prepared for today's lesson, so there's another element on here. But when we click this button, we are not editing the DOM itself. None of the HTML is being directly changed by us. Instead of what's being rendered of being all the HTML specifically, what React does, and I alluded to this for like 3 seconds, React has an index.html over here. Now you'll notice, so this is the head, none of that's really important for what we're doing. There's one div, the ID is the root, there's nothing in that div. That's the HTML document. That's what's being displayed on this page. Well, if we look at what that div actually is, this is where there's a lot going on. Robots.txt, what is that? So if we look at the index.tsx file, there's a couple calls here. Const root equals React DOM. So React DOM is the virtual DOM. The virtual DOM is what React renders and then gives to the virtual DOM and inserts into the actual DOM so that we can see what is on our page was first handled by React. So we're changing React, which changes the DOM. We're not changing the DOM directly. So we can see here const root equals the dom.createRoot. So this is just the root of our HTML tree. It's the top div. Is document, so that's just our HTML document that we just looked at. Get element by ID, root, so remember it had an ID of root. And then we see root.render, and we're seeing some components here. React.strict mode, you don't need to worry about that for now. I could actually rip that out and it would be fine. So it's rendering the app component. So that one div renders our app. Now if we look at our app, the app.tsx, in here we had a bunch of different routes. So we could go to, for example, button, we could go to query, we could go to the home page. And on each one of those pages, or those components, I should say, let's go back to the button. Button is a component that returns, and if we see there's some logic that we wrote in here. I'm going to make this a little bit bigger. Can you guys see okay? Cool. No one's saying no. The return value of this function is a div. This is returning, in this case, it was everything that's on this page. So we have the index.html goes to our index.tsx, which renders the app. The app here we have with a bunch of different routes. If we go to the button route, we will see what we saw before, which is this div is what's getting returned whenever we put button somewhere. It's a lot of steps. This is a lot of abstraction, but a lot of computer science is based on, we're not writing assembly, we're not writing machine code. we just abstract out the nonsense that we don't want to deal with anymore, and then give us something more friendly that we can work with. Instead of having to, for example, change the inner HTML for this button, we can now handle this behind the scenes with React. We can use variables in JavaScript freely. We don't have to use any of these get document or get element by IDs. There's a bunch like that. They're all not fun to work with. We can just write JavaScript. Instead of having to learn HTML and do all the heavy lifting and do the tedious work, we can just use our favorite language and write HTML in our favorite language. I don't know if JavaScript's anyone's favorite language, but you see where I'm going with this. I hope that made it a little bit more clear instead of me just jumping in and coding stuff as why React is actually important. There's a bunch of different JavaScript frameworks that are all sort of the same thing, and they're all kind of converging to have the same traits. Vue, Svelte, those are two ones that are pretty heavily in use. The idea is that no one wants to deal with the DOM themselves. They want to deal with the virtual DOM. Am I good? Are there any questions whatsoever hypothetically about why React is important and why it makes it easier? Cool. Let's get into it. So my plan for today is I'm going to be covering less material. I'm going to be going over every line, like literally explaining every line. If you guys can help me out just by piping up when you say, I don't know what that is. Why is there a bracket there? What is that type for? Please, it will make my job a lot easier. So I'm going to make a new directory. We're just going to start from the top. So I have created the directory, I've CD'd into it, I've initialized the repository. So control tilde opens up my terminal. npx create React app, my app template type script. I'm just going to run that. It's going to take a second. The idea is that what we're going to talk about today for the most part is going to be how we actually choose what to render on our page. Now that we know about state and how we manage state and ways that we can manipulate state, we're going to talk about how to choose what actually appears on the page. For example, what if we only wanted to show the button if it was, or the counter if it was even? What if, for like a more real world example, what if you wanted to get a list of people who tweeted at you, but you don't want to show anyone who you've blocked? That would be probably another way that is like a real world example. I guess in the real world it's going to be significantly more complicated than that, but we're going to see some examples here. So we've CD'd into this directory, we've created a React app. I have to CD into my app. Cool. So I have a bunch of files now in my app. And if I go to, I'm actually going to close the other React app that I'm running right now.
Can I ask you a question?
Yes, please.
So, like, I think this will be simple. So when you open a React, can you just explain like what all the different like folders are and like how to like navigate those, like what each of them means, like what does like SRC mean and like what all of it is?
Absolutely, that's a really good question. How you organize your project directories is something that is a little bit obtuse at first. It doesn't really make sense. This is the basic starter directory, and I can tell you what some typical folders would be for a front end. So let's take a look at this. I'm actually going to look at an older one where I have source and components. So my app is just the folder that I made or the directory that I made when I ran create React app. Created something called my app, which is going to contain all of this stuff in here. Here's the first thing, Node modules. Well, we're running Node. This is everything Node needs to function. We mentioned in our git ignore that this should all be ignored. We never touch this ourselves. We just forget it exists. Public. These are our public assets. These are things like files that we will be serving on this web page. So that could be our icon. That could be, let me show you. This icon up here is part of the public files. It's the fave icon. This thing called React app is part of the manifest. It's part of the public files that we're serving. We see this logo. Yeah, I think you remembered it had the spinning logo when we first, these guys are part of that. Basically, public assets are things that we want people to be able to access when they get to our web page. It's like PNGs, SVGs, things like that. This guy is a manifest, is basically some information about what the web browser does with our application. So we can see there's a short name, which is React app up there, some other information. That's public. Typically, we would be adding more things to that once our project has more assets. So I added a components and a pages folder yesterday, but I'm not going to talk about them yet. This is the app.css file. Just like with HTML, we can write CSS for a React. It's going to work the same way with a couple of very minor differences. So this is going to apply. If we look over at our app.tsx, we will see we are importing ./app.css. So we're using that CSS in this app. That's that. This test file, you don't have to worry about that. We're not going to be writing automated tests in this class. You ever had a professor uses an autograder?
Yeah.
It's this. We're not really focusing on that. Index.css. I believe that I wrote this for testing something. You can ignore it. It doesn't exist. Index.tsx. That's the file that we talked about. That's the root of the virtual tree for the DOM. Logo.svg. This is an SVG file. It's just a way to get images that are formatted a little bit differently than like PNGs. These aren't going to matter for now. Git ignore. We talked about this in our Git class. Package.json is pretty important. I alluded to it a little bit. Package.json is going to take contain all of our dependencies. Now, when we ran create React app, it installed all of these dependencies for us. We saw like the loading bar was going up and up. So you don't have to use create React app to make a React app. You can manually install any dependencies that you need. I'll tell you right now, you're gonna need React. That one's gonna be an important one. React DOM. I don't think you can make it without it, and so on and so forth. These scripts are just going to be for starting our project. There's some other stuff. I think those are kind of the main ones that I would care about. tsconfig.json we discussed when we did the TypeScript file. We see components. This is where I'm putting all our components in. I made that folder. That's just good practice. Typically, you have a components folder. Now, for a more complicated project, I might have, if I have 5 different components on my navbar, I might have a subfolder called navbar and then put my components in there. Pages. One good practice that you can get into is when you create a page, the page just renders basically all of your highest level components. So you're not looking at this wildly long page. Your page shouldn't be like 500 lines of TSX. Your page should be, it's my navbar component, my sidebar component, my main page component, my footer component, and then you can deal with all of those individually. Again, one of the reasons why we like React is because now we have all these components. We can just reuse that footer or that navbar on every single page. It's going to do the same thing every time. Typically, you'll see like a utils for like utility functions folder. You might see a hooks folder if you write your own hooks like we did yesterday. Did I mostly get your answer there?
Yeah.
Awesome. Thank you for asking. I really appreciate it. It makes my job easier. So I'm going to look at the button again, and instead of spending a lot of time writing the code myself, I'm going to go over line by line what it's doing for something that I've already written. So let's look at this button file. Now, we did the button yesterday. I'm going to I can comment out everything that we did not do yesterday. It'll still work. We don't need the use effect. That's not important for now. And we can get rid of this guy. So this is our button that we wrote yesterday, exactly what it is. What I wanted to talk about a little bit is how we can conditionally render some elements on this page. What if we only want to show the count if it's above 10? What if we want to only show the count if it's even? These are simple examples, but let's dive in and see how we can do this. So there's basically 10 different ways that you can do any one of these operations. Right off the bat, if I want to do only show count if count is greater than 10, what I can do, so I open my brackets here. Open my brackets is basically, I think of it as going into JavaScript mode. We can write JavaScript now. We're out of it, the HTML, into the JavaScript. So count greater than 10, and so I'm always going to be showing the 0, but if count's greater than 10, if I did this right, we're going to get a new element here, and I'm going to click to show you that it works, hopefully, and then I'm going to explain what's going on. Boom. So one way that's probably pretty easy, or at least readable to render components, is this syntax we have here: Boolean expression and then our HTML. So to write that on a clean line, it would just be something like const my var equals Boolean true. What this would look like in the HTML would just be like my var. So we have to open into brackets my var and then our HTML. Just like in AND statements, when you have, for example, A and B, so like if A is true and B is true, we do C. We can do the same type of logic with our components or our tags or elements or whatever we want to do. If my var is not true, we will not render this component. If it is true, we will render the component. This is, I think, probably the easiest way to do stuff. It's just a simple true-false. Now, if there's a lot of logic going on here, something that's a little bit more difficult than, for example, count equals to 10, we can write a helper function right outside of this. Const count is greater than 10. So I want to go over the syntax a little bit. And explain what's going on and why this is not going to give us the intended behavior. So if I refresh the page to zero everything out, oops. Sorry, there we are. We have a constant here, is a Boolean. It's equal to count greater than 10. So this will be assigned to be true if count's greater than 10, false if it's not. We're going to do the same thing. We just pass this in. This is a Boolean expression or a Boolean variable at this point. It's not even an expression. You can also make functions. Const is greater return count greater than 10. So now instead of it being a variable that we assigned outside of there, it's a function. This is, again, probably the most simplistic way that we can conditionally render. Now if we want to do something a little bit more complicated, what if we want to render one thing or another thing based on some value? For example, this is really, really common. If you have a landing page, you'll want to say either if a user isn't signed up, you want to say sign up or log in here. And if they are signed up, you might want to say, hi, John. Grab their username. Great. So we're going to display two different things based off of whether a user is logged in or not. So here's what I'm going to do there. I'm not going to make a whole user login thing. What I'm going to do is going to say count, enter JavaScript mode. Count greater than 10. So we talked about the ternary operator a little bit. Yeah, this is exactly what I want. Let me unprettier that before I jump into it. So this is a ternary operator. This is difficult to read if you haven't done a lot of these. I think it's difficult. I love using them now, but I swore when I learned about it that I would never use it in my entire life. It changed. So we have a Boolean expression. Count is greater than 10. This evaluates to true or false. The way I always read it in my head to remember is count greater than 10, question mark, like they're saying, asking yes. Well, if it's yes, we return this tag. Count is greater than 10. Otherwise, that's just what this little colon is. We return that tag. So let me save this. One of the reasons why I don't love these in React is because now when we formatted it with prettier, it does sort of get a little bit hard to read, I think, especially if you have some more complicated logic than just return this tag or that tag. But let's take a look. So I'm going to refresh the page because I changed some stuff. Count less than 10. Count greater than 10. So it changed when we needed it to change. I think that's a pretty important one. The last one that I would do, and I don't have an example immediately on hand for this, so I'm just going to show you with what we have. Let me just get rid of literally all of this. So it's back with our Boolean expression and. So one thing that you often do is you say, fetch some data from an API. Now data will be null before it's fetched, is typically how you'll instantiate it. And after you fetch it, there will be something there. It doesn't matter what it is, there will be something. So what you can do, if we can just pretend that count as data here, or you know what, let me do it just a quick data. Cool. So if data is not null, we should have a tag here that says hi. If data is null, what we can do, let me just say data equals null. It goes away. That's again, just using the and operator. But this is so useful. And what you can do a lot of the time is just a simple no data. You can also do, this is asserting that data is real and that there's something there is the double, I can't think of what that punctuation mark is called, exclamation mark. But you don't really have to do that most of the time. So we talked a little bit about conditional rendering. Does anybody have any questions literally about anything? What's up, Reed?
Something that I want to make sure is clear and important and emphasized is that when we're using set state variables, like when we're using the use state hook and using these state variables, React is automatically detecting when one of those variables is updated and then reapplying that conditional logic every time. So that's one of the many beautiful things about it is like it knows that count is updated and then it rechecks that conditional rendering every time count changes automatically. That's not true if it's just a non-state variable, right? So if you were just going to declare const data before the return statement, React doesn't necessarily, it wouldn't check that every time unless it was a state variable.
I think that's a really important thing that I did not bring up, but it does bring me to a slide that I wanted to talk about for a little bit, and it's about the component lifecycle. So the component lifecycle has 3 stages. The component is created, it is inserted into the DOM, and it's rendered for the first time. That's the creation stage. It's called mounting. If you want to sound fancy, you just call it mounting. It makes you sound like you know what you're talking about. The next one is called, it's the updating stage. I think officially it's called updation, again, if you want to sound fancy. So there are a couple of things that can cause a component to update. If you update the state that component is associated with. If you update the props that you pass into that component, that will re-render a component. Now what's really cool, and one of the things that makes React more performant than old-style JavaScript, is that it's only re-rendering what it needs to re-render. We're not re-rendering, if we've written this correctly, We're not re-rendering an entire page. If you see like, you know when you refresh a page, you see like everything goes away and then it loads. We should never see that in React unless we've done something horribly wrong. And then finally, the unmounting is when the component is destroyed and it's taken out of the DOM. So when we update state and when we update props is when a component itself is updated. I think that that's something that's really important to remember, like Reed said. Thank you for bringing it up. So I want to talk a little bit about how we set state on objects. And then I'm going to write a little bit of CSS, or show you a little bit of CSS that I already wrote. So I don't want to spend too much time writing code today. I think I made a route for this. Give me a second. Person. This might be the home page. Cool. Okay. So a person here, if we go to our pages, our home page has a person on it. There's a couple of things going on here. I want to walk through line by line. Up here at the very, very top, we have two import statements. Typically, we'll be importing two different things. We'll be importing things from outside our project. So this is our import React use state from React. You'll see me, if I see something underlined in red and it says this is not defined, like use state, what I'll do, just to grab it, is I will command period on that and just add all missing imports, or add import from React. Problem solved. The other one is that import person. Well, person is something that we made, or that I made before this class. And to import that, you need to find where this is in your directory. So ... is just go up one. So if we go up one level, then we go to components, then it's in person. So now we can use the person component. And same thing, just period and command will let us do that import automatically. So this is our homepage component. We immediately have an interface that I declared. An interface is just a type. It is for all basically anything that we want to talk about. It's the same thing as a type. A person's going to have a name, an age, and if they're married or not. Is just how I described it. So that's our interface right there. I declared a static guy. So guy is just a person. It's const, so I can't change guy. It's constant. Tim is 25 and is married. This Boolean I'm actually not using anymore. So here's where we're doing some React. This is our use state hook. We used it a couple times yesterday. Use state is always going to follow the same format. Const, an array of two things in it. So the first thing is, in this case, it's going to be a person, because we say in the hook over here, this must be a person. And set data is a function given to us by React. To be super specific, this is a dispatch function, but it's hypotheticals. We just want to focus on making stuff work for now. We're using the use state function, and we're instantiating it to be guy. So on the very first render of any components that are associated with data, when the component mounts, this is what guy is going to be. Now, we have a handle set data here. We talked a little bit about how to set data for number, or how to set state for numbers. You would just say set state, or if we called it count, set count +1. Set name, James, if we need to do a string. But this isn't a string, this is an object. How do we set the state of objects? We can't just edit one property on the object and call it a day. We have to do something called object spreading, which we talked about for about 30 seconds in TypeScript. Let's take a look. This line looks a little bit weird until you're used to it. I'm going to retype this out so I can walk through exactly character by character. Set data. So set data is our function. That's our special React function. So we just have to pass in exactly what we want our data to be. Now, person's an object. We have to give this an object. We can't just give it a name. It won't. TypeScript would yell at us if we say we want to set the name to be Tim or James. Immediately yells at us. TypeScript knows that we messed up, and we can see we need a set action state for a person. It needs a person. So we do the brackets for objects. Always brackets for objects in JavaScript. Now we need to spread the object into the current object. What that means is you take all the properties of the object, put them in another object, you can think of it as a copy, and give it the exact same traits. But we want to change some field here. Let's say that we wanted to change his name or his age, or it's not important. So the trait that we want to change here is person. So we use that field person and just say James. We now have a new object with all the same properties as Guy, except the person, so their name, is just going to be different. Questions? It's kind of weird. Awesome. So down at our function, or down at our HTML, so we're returning the HTML like we've done before. I mentioned this a little bit. You'll notice that I'm always wrapping my components with a div, one single div. If we wanted to do like one div over another div like this, huge errors. When I see that many red lines, I always panic a little bit. It never goes away. But what's happening here is we need a root. This essentially, there's a div next to a div. We need a top element here. Before we just had one div that was on top. We just need to return one thing that's wrapping everything else. So that's why you'll always see me, if not wrap it in a div, it'll be just wrapped in one component or another. It's just one thing on top. So this is our button. On click, when we click it, we pass in the handle set data function. So handle set data should be changing the state of this person object to have the name James. Let me refresh this page. There we go. So let me show you exactly what happened. You'll also see that's in red. We're going to go into that next. But we spread the object, and then down here in the person component, we're rendering a person component. Now, if I go into person, I mentioned this yesterday, Command P gives us all our files. You can just type in person and it'll come up. Command P is one that I use a lot. Command Shift P, also extremely important, goes to your most used most used VS Code commands. You'll see organize imports. Happens a lot. I actually want to show you what that is right now before I show you the person component. Import, it can't be a CSS file. I'm actually trying to find something that we don't need. This is... You know what? I don't want to waste time on this. There's more important stuff to talk about. So if we look at our person component in TSX, we have our interface here, which is our person props. Person has a name, age, and is married, just like before. We also had to give them the function for change name. Remember, we're controlling state here, and this is really important. I talked about this a little bit, but I don't think I explained it in enough detail. We have to consider at what level the state is owned by, so to speak. Where does the state live? Now, the state that we're talking about in this example is this data. This lives at the level of home page. It's on the home page component. That's who ultimately has access to the state. That's who can control it. But we want this button, and the button is part of, oh, I'm so sorry, the button is not part of it. That's the change name button. We can also do this. Okay, so I made this if we have multiple persons, multiple people, but we will see in the person component, if we wanted to change the name here, we have to pass in this function from above, the change name function. The change name function is the handle change name function. that we wrote at the higher level, we have to give that function and the state to the child component so that the child component can access it. This is called, once it accesses it, it gives the state back to the parent component. This is called raising the state up. If you think of it as a tree structure, I'm sure that there are people who have taken data structures, encountered trees. If you think of it as a tree structure with the parent being the root, you may have to go down one level. In this case, you go down one level on the tree to get into parent. If parent had another child component that we wanted to access the state, we would then have to go into, I don't know, the person's dog or whatever, child component of that. And you just have to keep passing that function down and down and down and down. Again, it's one of probably the biggest criticisms about React is that when you have a pretty complicated page and you have to drill down through 5 child components to get to the state, it can be a little bit hard to manage and debug. So in this component, we are passing in the props. We're passing in person, age, and is married. Person, age, and is married, which we are getting from the parent component. We are saying if the name starts with J, we have a function here. It just returns true if the name starts with J. I don't believe that I did use that function. And then this is just our basic HTML. So we're saying person. Now you'll notice in this tag in line 18, this is just a tag that has an ID equal to a name. Now, we haven't done CSS in a couple lessons, but we can write CSS exactly the same in React, for the most part. Reed will probably be able to tell you more about the discrepancies than I would. We can write it the same as in React as if we were just doing raw HTML. So, let's take a look at our person.css file, which is one that I wrote. And we'll see in the project structure, I put them in the same place. Reed, is that what you do, or do you put all your CSS in a separate directory?
It doesn't matter. Like,
it's personal preference.
sometimes you'll see like how there's like a components folder, a pages folder. There'll be like a styles folder that then you put all your styles in, or you can put them in the same folder.
I usually put them right next to each other so they're easy to find for me. It can go either way. So we see over here, we just have our selector for person. And then a whole bunch of stuff if it's a person with the name, person P, person H2, etc. So this CSS, if we go back to person.tsx, we'll see that I'm importing this. We are importing the ./person, so same directory, should be right next to it, person.css. And we'll see the class name for person. We were saying that all of these are part of the person class name. We're saying that the ID here, if we want to target this one specifically, like let's say you want to make the name underlined or something, that would be how you target it with the ID specifically. Of course, there's usually multiple ways to do something, but this is one way that we can target specific elements. Again, sort of the point of this lesson is to show that we're doing all of our HTML and all of our JavaScript and all of our React in one place, and it's scalable, because we're working at it at a component level. So we just build out one component to be how we need it, and then we can replicate that component as many times as we need on the page. The example that I always use and have alluded to, the YouTube video thumbnails. We can just do it over and over and over. So to continue here, we will then see pH. That's simple enough. Now, we have a ternary operator over here. Before you saw me do the ternary operator outside of the tag. So you would see P is married, question mark. These are going to be the exact same thing. It's just done a little bit differently. I wrote it this way to show you, just getting you a little bit more familiar with React and the HTML in React. So the top line, line 20, we're always showing this p tag no matter what. Inside this p tag, we go into JavaScript mode. If is married, question mark, so if that's true, the text or the string within this p tag is going to be married. Otherwise, the string will be not married. So we can see that we're always rendering one p tag, and what the p tag has in it will change. 21 will be the exact same thing no matter what, But in this case, we're not always rendering the same p tag. We're rendering one p tag or another p tag. So same thing, ternary operator. If it's married, render this p tag. Otherwise, this p tag. Syntactically, it looks a little bit odd. Same exact thing. I'm just doing a quick check-in. Does anybody have any questions? Okay. So, over here, just more ternary operators. Simple enough. I want to, do you think I should get started on use effect, or just, I think I just want to save it all for next time. I don't want to jump in for 10 minutes on use effect. So another thing that I wanted to talk about just a little bit. So I want to make an example of drilling down deep for a component. So I'm going to make something real quick here on my home page. I'm going to wipe out my home page entirely and just give you a little bit of an example about what prop drilling means. Because the first time I had to really deal with it, it was tedious. So we go to our home page. We got a lot of stuff going on in this home page. So we have a person component. So right now, so far, we've only nested one component inside another. Let's put another component inside person. So let's say that this person tag was getting complicated and we wanted to, I don't know, instead of having something for the whole is married deal, let's just even keep it easier than that. Let's do one for age. Let's say that instead of rendering a p tag here, we're going to want to render an age component. This doesn't exist yet. VS Code's going to yell at me. So I'm going to make a new component here for age, and I just want to show that. Age.tsx. So I always do, my snippets are just, this is my workflow. Get everything immediately. You can download snippets from the extensions. There's like 7 zillion different React snippets. You can just find one that works for you. When you've written 12 zillion components, writing the same boilerplate for every small file is tedious. So age props, we just want to give it, let's say the age. So this is our component. This age props here means we're passing in the age props. We're going to destructure. Now destructuring is we take our object, and we reference fields specifically by it. So we put the angle brackets, we just type age, and now we can talk about age instead of having to talk about props.age. The other way of doing this would be if we just pass in props.age. You'll see we get autocomplete because it knows that props is of type age props, and the only thing that we have there is age. So that's why we get the autocomplete feature there. But I always destructure, just makes it a little bit easier. So let's keep this component very simple. Cool, that's exactly what I was going to do. So that's our age component. This is just a div. It's going to have a header tag on top that says age. Right under it, it's going to say p, which is we'll have our age. So we now need to import this age component. This is something we've written. It's elsewhere in our project. This particular module doesn't have that imported yet. Now, I've shown you the shortcut. What you can also do is import, if you want to be like a caveman or like from the 90s or something. That's not even right. One sec. No, it is. Okay. You'll notice that we still have a problem here. Again, this is why I love TypeScript. It tells us exactly what we need to do. Age is missing in this component, but it's required in type age props. Well, we have to give it a number. And the number that we have to call it is called age. So this is really, really useful. This is a VS Code trick. If you type control space, it'll give you a list of options of things that it's expecting. I never remember what I call my variables ever. I just control space and go, oh, it wants age. Enter. And our age is going to equal, well, it's going to be our age. So we are no longer on the person component. Let's zoom out for a second and go to our home page. Our home page has a guy. It's an object. He's got an age. That's a number. That's what our state is. It's just this object. It's a person object. When we are displaying this on this page right now, what's being rendered is this HTML, and then this component that we wrote, the person component. Person component is being given the data.person, data.age, data.etc., and this function of handle set data. All of those we are passing to person as props. Person gets all that information to work with. In this case, it's 3 primitive variables and a function. And this HTML tree is rendering just those things in person. Well, if we want to know what person renders, let's go to person. So Command P, person. If we go to person, we will see that person is in fact getting the person, age, and is married. We're doing some logic up here. And then over here, we are returning one div. This div is wrapping a bunch of stuff. There's some CSS going on. We have HTML, more HTML on the bottom. And then let me just rip that out because it's not really helping my case here. And then age at the very bottom. Age is a component that we wrote. So we have to pass it age, which we got from homepage. So we're going from homepage as age, pass to person, pass to age. So this piece of state has now gone down 2 full levels. If we go over to our age component, this is where we're actually displaying age itself. We display the age component. The age component is a div that wraps a header and a p tag containing the age. Questions? Does the structure of we have to take state at a high level, bring it down 2 levels to display it there, make any sense? Okay. And intuitively, I have about 5 minutes left. I don't have it. Let me see if I can do this pretty quickly. I don't want to rush. Let me see if I can change the age at a low level. So let's say that I want to be able to actually edit age down here. Let's say that I'm displaying, 50 people, and I want each one of them to be able to edit their age individually. Well, to do that, I need some way of accessing that state that's associated with the lowest level component. To do that, we have to have a function controlling state all the way at the top level, give that function to the bottom level, and then raise that state back up once it's modified. I'm going to try to do that. Give me 2 minutes. So homepage. And we change name, const name. So instead of changing his name, or the name, we're going to change it to age 50. So right now, we'll see that we are in fact changing the age. When we are showing the person is showing the data.age, et cetera, et cetera, et cetera. So when we modify all the way up here, when we are modifying the age down here, and we are giving that state to the person, to the age component, which is displaying the 50, is getting it from 2 levels up. But let's say that we don't want this button to be all the way at the top. Let's say that we want this button to be part of person, because we want to control it at that level. Or age, excuse me. So change. We're going to call that function change age, which means I need to change it in person. Let's see, and then we need to give change age equals. And then I have to give that to the age function. Missing type age props. See, I didn't give it So what happened there is it said that I was missing in the props. I look at the props. I did not give it change age. Type person is unassignable. Change age, change age. Cool. Cool. We did it. So let me explain again what's happening. What we have here, we are declaring at the home page level, at the top of this tree, we have this change age function, which is going to set the data and set our state to be the same object, but we make his age 50. We give that function to person. Change age, which we pass in, is change age. We check out person. In the props for person, we see the function. It just takes nothing and returns void. We pass that in and destructure it. We then give it to age. Age is also going to have, the component age is also going to have something that we call change age, so it's going to have that in the props. And then when we go to age, we will see change age up, that's in the props. We pass it in the props. And that's where we're finally accessing it, is at age. So in this way, if we had 20 different people and we rendered all of them on our page, there would be a change age button for each one. Clicking one button would only change the age of the person that button is associated with. So the component that's associated with the age, so the person component, that person's age will be changed to nothing else. This is sort of a pretty simplistic example. It will make sense when you do it. It's not going to make sense when I tell it to you, at least speaking from personal experience. With the 2 minutes we have left, are there any questions? What's up, Gordon?
Is there a reason you put the state of the age also in the, like, all the way down the page rather than at the top, so that you don't have to pass it down?
Well, if we're putting that all the way at the bottom, when we display the page at first, we would have to drill all the way down into the age component itself and pass it back up. Just the way that this page was constructed, we have it at the top level. It's you getting state from children can be tricky in React. A lot of times it's easier to have it at a higher level. Like for example, if here's the point on the tree and we need a component way on the left side of the tree and way on the right side of the tree, you need to be able to access the same state. They don't have any way to get it to each other unless they go to their nearest ancestor that they have in common. Then the state has to be controlled at that level. It'll make sense when you do it, I promise. I have a question for you guys. Was this lecture a better speed? Okay, it's good to know. Thank you. It makes my job easier. I promise it does. I will see you guys on